All right, so we are studying physics, but a little bit of a question. We have a Q&A for Gemini. The question I proposed was, is there such a thing as a Brachistochrone curve for light traveling through space? In other words, is there a path light can travel along that would make it travel faster than light somewhere else in space? Which seems like a dumb question, like just because like space curves, light travels in a straight line. Well, it does travel in a straight line, but it seems to curve because space curves. And so it's always traveled on a straight line. And so I know the answer is no, but I just want to see out of curiosity what Google says. So we'll delve deeper into it to get more details and see exactly why and see if there's any other information it presents to us. So Gemini responds, no, there isn't such a thing as a Brachistochrone curve for light traveling through space. Why a Brachistochrone curve for light doesn't exist. A Brachistochrone curve is the path of fastest descent for an object influenced by gravity from one point to another. The object, typically a sphere or a bead, travels along this path quicker than it would on a straight line because it accelerates, gaining speed as it travels downhill. This concept is fundamentally tied to the idea that the object's speed can change as it moves. However, a Brachistochrone curve for light is not possible. Light travels at a constant speed, c, in a vacuum. It doesn't accelerate or decelerate in free space. The fastest path for light to travel between 2 points in a vacuum is a straight line, which is the shortest distance. The very definition of a Brachistochrone curve relies on an object's speed varying along the path. Since light's speed in a vacuum is constant, there's no way for it to gain time by taking a longer curved path. The concept is therefore not applicable to light in a vacuum. Solid answer. Light traveling faster than light? No, there is no path light can travel that would make it travel faster than light somewhere else in space. The speed of light in a vacuum, c, is the universal speed limit. According to Einstein's theory of special relativity, nothing can travel faster than c. While light can appear to slow down while passing through a medium like water or glass, this is because it is absorbed and re-emitted by the atoms within the medium. Its actual speed between the atoms is still c. Cool. That's actually kind of cool. Good way of putting that. The idea the idea of light traveling faster than c anywhere is a direct violation of one of the most fundamental principles of physics. So no. Can't try. There's no Brachistochrone curve for light because light travels in a straight line and always travels at the maximum speed. So nothing can travel faster. All right, cool, got it. I thought that was gonna be a longer video, but guess not. That's fine. On to the next one.